All right. Good afternoon, everybody. Hope everybody's doing great. Everybody's all right. Is this in the way of everybody? This in the way? Oh. All right. So hope everybody's doing great. We're gonna go ahead and get into the lecture today. Yes. Yep. So talk to me after class, make sure you're straight. All right. So like I mentioned last class, we're going to get into the lecture today. We'll do a couple sections, B1, B2, both of them are light sections. So send the email out. Some of you already found out that you are able to log into WebAssign. I know a couple people from my previous class had some issues. So if you have any issues, just shoot me that email so I can let the reps know that there's still some people having some issues getting into WebAssign. But we just operate accordingly. Best way to handle your work, of course, is not to wait until 5th week grading. Remember, I told you we have 3 due dates that we're going to be using as markers. We got 5th week grading, 10th week grading, then our final grading. So when you go into WebAssign now, dates, I think one of the first dates is 8/24. Don't worry about that. I am going to change it to, like I said, to what I said before, which is 5th week grading. So don't worry about any of the dates right now. I will be changing them very, very soon. Just haven't gotten into it yet. Let's see what else. Okay, so like I said, don't wait until the weekend before 5th week grading to start doing this work. You don't want to put yourself in a position in which you can't walk away or take a break. You always want to, do this thing progressively as we go throughout it. When it comes to the pacing, if you want to make sure you're staying on track, all you do is do the sections that I covered. We'll do B1 and B2 today. So B1 and B2, something you can go ahead and knock out. There's no harm in moving ahead. But when you get in there, you're gonna see all of your assignments from beginning to end. So if you want to move ahead, feel free to do so. There's no penalty for that. And I would even encourage it. If that's, if you're comfortable with the topics, feel free to go ahead and move ahead. You never know, we may run into a roadblock that may stop you or slow you down. So with that being said, let's go ahead and get into our first section, evaluating variable expressions. So, also I want to mention that this book assumes that you know certain things, that you already come in with some pre-knowledge, so it doesn't take you all the way back to arithmetic. So if you're not comfortable with fractions or decimals or adding, subtracting, multiplying, dividing, sign numbers, then most definitely you have to get with me, make sure your foundation is straight moving forward. Probably going to send some videos just to give you, if you want to look at it, of me just talking about those sections. I mean, those topics in previous classes, talking about the rule of sign numbers and stuff like that. But you just want to talk about it, make sure you cut them office hours or email me, and we can make sure we set up a time when we can make sure you're okay moving forward. So variable, which is the letter used to represent any unknown number. We have 26 letters of the alphabet, so A through Z are options. Normally, we use X to represent our unknown number, but that's always talking about just letters that we use to represent an unknown number. A variable expression is just an expression that contains one or more variables, plus and minus signs, operations as well. So right here in the green, I have an example of a variable expression. Doesn't have to be this long, but that's just an example of one. So it's 3x squared minus 5y plus 2xy minus x minus 7. And as we go through the notes, if I scroll up and still copying or move too fast, also feel free to let me know. I can pause or go back down so you can see what I put up, whatever the case may be. So when it comes to your expression, we're going to have terms, and the easiest way to identify your terms is by recognizing that it's separated by the plus and minus signs. Anything that's positive stays positive. Anything that has a minus sign is considered a negative term. So 3x squared, that's positive 3x squared. Minus 5y means negative 5y. So if you want to keep your equivalency, you can never remove that minus sign or negative sign from the 5y. The 5y is say negative. 2xy, negative x, and then negative 7. All of these are considered terms. So I'm holding on to the blue up top. Blue. And then if you hear the term constant, constant is just a number without a variable. That negative 7 would be considered our constant. Scrolling up some. Oh, that note right there, go to order of operations. That's for me. So I can move to another page. So you check a chance to finish up, then I'll shoot to another page. All right. Can I go to the next page real quick? All right. So order of operations is something, another is one of those things that they are expecting you to have experience with coming into the class. I just want to touch on it real quick to make sure we're okay before we continue to move forward with it. So order of operations, PEMDAS, we used to say, please excuse my dear Aunt Sally to remember the order. This is one of those things where a lot of people get mixed up in because of certain things that aren't emphasized enough. And so, you know, you may see something like this, or may get a math problem on social media somewhere, and then everybody going back and forth about what you're supposed to do first and all that stuff. Well, this is why a lot of people get this mixed up or get the answer wrong because they don't really know the true order of operations. So when we look at P, when you first introduce the order of operations, normally you're just using a parentheses, so that's what the P is for. But when you get to this level, any grouping symbol should get your attention first. So it's not just parentheses, but brackets and braces. Any grouping symbol should get your attention. All right. Second are your exponents. The second thing that should get your attention after you're taking care of what's inside your parentheses, exponents will be next. After that, notice the third level, we have 4 tiers of operations here, even though we have 6 letters. The third level, you have multiplication or division. And this is where it gets a little dicey for some because they think the M is always going to come first, or the multiplication is always going to come first before division. That's not necessarily the case. You do those from left to right. Multiplication and division are seen as being on the same level. So if division comes first, you do that over multiplication. And then the same thing with addition and subtraction. You do them from left to right. They're seen as being on the same level. So you have 6 letters, but only 4 tiers of operations. Scroll up. Good. All right, here, just want to do this light example to make sure we're okay with order of operation, that left to right thing, and how even though you may come down to a solid number, it does not mean you have the correct answer. So here I have 18 divided by 9 times 2. So if we just stick to the fact that M comes before D in PEMDAS, it would force us to do multiplication first. 9 times 2 is 18, and then 18 divided by 18 is 1. So notice we get a solid number right here for an answer, but it is incorrect. So the way we're supposed to handle it, once again, multiplication and division, you do them from left to right. So we should take care of our division first. So 18 divided by 9 is 2, and then 2 times 2 is 4. So this is our correct answer. So just want to make sure that we see what we mean by going from left to right, you know, and then also just because you come down to a solid number does not mean you actually have the correct answer. Everybody okay before we go back to the other set of notes? Make sure we're good. All right. So that takes us into evaluating these expressions when they give us a certain number for the variables that we have. So we have x squared minus 3xy, excuse me. And they want us to evaluate when x is equal to 3 and y is equal to -4. So that just means we're going to plug in 3 for x and then -4 for y into the expression. So that's what we did right here. So that'd be 3 squared minus 3 times -4. So whenever you have numbers right up against letters like that, that implies multiplication. So that's 3 times x times y. So once you plug it in, it's 3 times 3 times -4. So you look inside your parentheses, notice there's nothing to do inside of our parentheses. If there were, then we would be doing it, but there's nothing to do. So the next thing we need to look at is our exponents. And that's what happens here. So we look at 3 squared. That just means 3 times itself twice, which will give us 9. So we have 9 minus 3 times -4. Then we go ahead and do 3 times 3, which is 9. So we're here, 9 minus 9 times -4. So here we have signed numbers. Once again, that's one of those things where they expect you to be okay with multiplying signed numbers. You have -9 times -4. Negative times negative is positive, so it gives you a positive 36. And 9 plus 36 is 45 for our final answer. So don't forget that when you're doing your test, I expect to see some kind of work. Remember I say you can email it to me or come to class, show me, but whatever the case may be. But something like this, you don't necessarily have to show me every single step, but some type of work in which it validates that you did something. We all know you can throw that in the calculator. We all know there's apps out here. But I do need to see something other than I'm just shooting breeze, right? So make sure that you show some type of work when you go about doing these problems. Show that you put in some type of energy into doing it. Yeah. Questions on this one before we go to the next? All right. Next one, we have a squared minus b squared over a minus b. And they give us a is equal to 3. And then b is equal to -4. All right. So plugging in 3 for a and -4 for b. So that's 3 squared minus -4 squared over 3 minus -4. All right, so we have 3 squared once again, and that's going to be 9. 3 times 3 is 9. Now be careful here. We have these two negatives. Those two negatives don't touch each other because of that square. So we have to take care of that square first, and what's being squared is -4. So that's -4 times -4, which is a positive 16. So notice that this minus sign is not affected by anything. It's still there. So be careful when you're doing your work and how you deal with these negative signs. Now down here, there's no exponent, so that negative does turn positive, and that'll give you 3 plus 4. All right, and then so on top, we have 9 minus 16, which is -7. On bottom, 3 plus 4, which is positive 7. Then -7 divided by 7 is -1. Any problems with that one? Should be good. And okay, so that's it for B1. So that's the type of problems that they were setting you up for in B1, just evaluating. So make sure you're okay with plugging in values and then calculating accordingly. Also, if you're gonna come to office hours or ask me for help or anything like that, please make sure that you bring problems to the table. Don't just say I got a problem with solving equations. Actually bring some equations that we can walk through. That way I don't have to go looking for stuff because I can find 5 problems and it still may not address the issue that you had with the problem that you saw. So make sure you do your part. Just go into the homework, pull a problem out. Simple as that. I mean, you don't have to say, oh man, I tried this and that. I mean, if you just go in there and you look at number one and you just don't know how to do number one, bring number one. You know what I mean, I'm not asking you to do anything crazy, but just, bring problems that I can work with. And then from there, I can look at the problem you gave me and then pull more problems similar to what you brought. So that's all I ask is that if you ask me for help, that you bring something that I can work with, and then we can go from there. So I said something in the chat. You said, no, fifth week grading. Fifth week grading. So the fifth week of this course is what it be. I haven't mapped out what date that is, but yeah, the fifth week of the course. Yeah, no problem. So your classmate had asked about what I said about fifth week grading, due date and everything. So that's all. All right, so are we good to go? Scroll up, scroll up. All right, so let's look at this section and then we'll be done for the day. So simplifying variable expressions. All right, so in order for us to be able to simplify our expressions, we have what we call like terms. Like terms are terms that have the same variables, same amount of variables, same exponent on the variables. If anything is different, then they are considered unlike. The reason why that's important is because like terms means that I can add them and subtract them from each other with no problems. If they're unlike, I can't do anything with them. So, pull it up a little bit. There we go. So, see in my like term category, we have 3x and 5x. Example of like terms, negative 10x, y, 8xy, 21x squared y, negative 100x squared y, and then 7 and 11. Constants, they're considered like terms as well. Once again, those are terms that we can add and subtract from each other, no problem. They have the same variables, same amount of variables, same exponent on variables. And that's what makes them like. Now, if anything changes, they're unlike. So you see 3x and 5, one has x, the other one doesn't, so you can't add them together. Negative 10x, 8y, one has x, the other one has y. 21xy, one negative 100x squared y, one has the power of 2, the other one doesn't. And then for the last example of an unlike set of terms, we have 21x squared, xy squared, and then 100x squared y. So the power of 2 is on different variables, so they're still considered unlike. All right. So enough. If I go up too far, once again, let me know. Now, what I'm doing right here, just giving you similar scenarios just to reemphasize what I can add and what I cannot add together. Just dealing with the 5x and 3x. Just in each case, something is slightly different. So 5x plus 3x is going to give me 8x. All I would do is add what we call the coefficients. Those are the numbers that are sitting in front of your variables. So 5x plus 3x, do the 5 plus 3, that'll give us 8x. Once again, that number that's sitting in front of your variable is called your coefficient. Looking at this next example, we have 5x plus 3y. I cannot add them together, so that expression is considered being already in lowest terms. So that's what it is, lowest terms. If you have an expression and either you simplified it all the way down or you couldn't simplify it any further, it is considered in lowest terms. All right, so the next one, 5x squared plus 3x squared. Notice both of them are x squared terms, so you just add the coefficients, that'll be 8x squared. Notice the power of 2 does not change off of the x once on the x that, once you add them together, all you're doing is adding the coefficients. So that'll give you 8x squared. Next one, negative, not negative, 5x squared plus 3x. One has the power of 2 on the x, the other one doesn't. So that's already in lowest terms. You can't add that together. And then 5x plus 3, can't add those terms together either. It's already in lowest terms. All right, good. All right, so we're going to talk about a couple of properties that they brought up in this section. Talk about these, and then we'll go ahead and evaluate. I'm not evaluate, simplify, and then we'll be done with the section. So first thing we do is looking at commutative property. So we're looking at addition and multiplication. Subtraction and division, we have to consider some other things before we just switching things around. So all we're doing is looking at addition and multiplication. So A plus B is equal to B plus A, or A times B is equal to B times A. So just saying, it doesn't matter which position, well, which one comes first or second. If it's addition, doesn't matter. If it's multiplication, doesn't matter. So 4 plus 5 and 5 plus 4, well, 5 plus 4 will still give you 9. 8 times 3 and 3 times 8 still gives you 24. Hmm. Next one is the associative property. Once again, we're just looking at multiplication and addition. So if it's all addition or all multiplication, it does not matter which one or which two numbers you do first. As long as you do it correctly, you'll still get the same answer. So if you're looking at addition, 5, 1 plus 2 plus 3. If I add the 1 and the 2 first, that'll give me 3. Then 3 plus 3 is 6. Or if I do 2 plus 3, I'll get 5. And then 5 plus 1 will give me 6. Either way, I will get the number, the same number. So that's the associative property. I hold on to the red up top. All right, next property is distributive. So you have A times the quantity of B plus C. All you're gonna do is to distribute A amongst each term that's inside of the parentheses. So that's A times B plus A times C. Yep. Yep. Right here. Mhm. You good to scroll up? I didn't tell you. How we with the red up top. Hold on. All right. So let's distribute a few. So if I have 3 times x plus 2y minus 5z, so it just means I'm going to take the 3 and distribute it into each term. In the parentheses, 3 times x is just 3x. 3 times 2y is 6y. 3 times 5 will be 15. Mhm. Let's go up. All right, so the next one, we have negative 4a, well, negative times 4a minus 9b plus 12. I guess we said negative times the quantity there. Anyway, we want to distribute that negative into the parentheses. So just like that 3 was up against the parentheses, and we saw that made us distribute. Same thing with this negative sign. This negative sign is right up against the parentheses, so that tells us to distribute. So a lot of people make that mistake and they don't do that for whatever reason. I guess the minus sign doesn't carry the same effect to some people, or they'll just give the negative to the 4a and forget the other term. So make sure you're careful with that. That minus sign has to be distributed to each term in that parentheses. And what it's going to do is it's going to change the sign of each one of those numbers. So it was positive 4a minus 9b plus 12. So negative applied to that 4a gives you negative 4a. Negative to the negative 9 is a positive 9. And then negative applied to the 12 gives you a negative 12. So each one of those signs go to the opposite sign. All right, questions? Everybody okay? All right, one more like this before we go to another one. Another set, yeah, another property. So let's say if I want to distribute a fraction, here I have 1/2 times the quantity of 6x plus 14 plus 10. First, recognize that the 1/2 does not go to the 10 because the 10 is not within the parentheses. So it only is going to hit the terms that are in the parentheses. So that's 1/2 times 6x plus the 14 is 1/2 of 6, and then 1/2 of the 14. So you look at this a couple ways. One way we can look at it is that 2 stays in your denominator even when you do the multiplication. So that's 6x over 2 plus 14 over 2. Over here, just emphasizing the fraction process. You can look at 6 as 6 over 1, and all you do is multiply across. So whatever way you want to look at it, ultimately you're supposed to have 3x and 7 after you apply the 1/2 to each one of those numbers. So 6 divided by 2, and then 14 divided by 2. And then to finish off the expression, whenever you have, after you're doing your distribution, if you have like terms that can be added, then you will be expected to do so. So right here, notice we have 7 plus 10, and that'll give us 17. And that'll give us 3x plus 17 as our most simple expression. Mhm. All right, everybody good? All good. All right, got two more properties and we'll be almost finished. So next one's identity property. Just saying that anything plus 0 is itself. For addition, and then for multiplication, anything times 1 is itself. All right, inverse property. For addition, a plus is negative, which is negative a, or any number plus is negative is going to give you 0. And then for multiplication, any number times its inverse will give you 1. All right, so we see we have 5 plus negative 5 is 0. And then 5 plus 1 over 5. Bless you. So if you have 5 times 1 over 5, then ultimately you end up having 5 over 5. You see how we have 5 over 1 plus 1 over 5. That'd be 5 over 5, which reduces down to 1. All right. Let's see writing. Going up. Very good. All right, so simplify a couple of expressions, and then we'll be done for it. So first one, we have 3x plus 4y minus 10x plus 7y. So what we're going to do is look for our like terms. Notice we have 3x and a negative 10x. So that will give me a negative 7y. I just said 7y, negative 7x, which is right here. And then we have 4y plus 7y, which is 11y. Next one, negative 3 times negative 5a plus 7c. So we have negative 3 times the quantity of negative 5a plus 7c. So we distribute the -3 into the parentheses. -3 times -5 is +15. And then -3 times 7 is -21. So this next one, we have 4 times the quantity of x minus y minus 2 times the quantity of -3x plus 6y. Distribute the 4 first. 4 times x is 4x, and then 4 times y is 4y, so it's 4x minus 4y. And then here, be careful. You have to distribute -2, not just 2. Once again, sometimes people make a mistake and they'll distribute just the 2. And I'll leave the negative there. That negative or that minus sign is attached to the 2, and that needs to go wherever the 2 goes. So that -2 times -3 will give you +6x. -2 times 6 is -12y. From there, combine your like terms. 4x plus 6x will give us 10x. And then -4y, -12y will give you -16y. Mhm. Any problems, any problems? All right, so this next one, we have not negative, but 2x minus 3 times the quantity of 2x minus 3 times the quantity of x plus 7. So notice we have 2 sets of grouping symbols. We have one grouping symbol embedded inside of another. Whenever we have something like that, you always want to work your way inside out, do your innermost grouping symbol first, and then simplify as much as possible and keep going, like I said, from the inside out. So the first thing we're going to do is look at that -3 times x plus 7. So we distribute -3 into the parentheses, and that'll give us -3x minus 21. Right here. Now, still inside of our brackets, and I didn't mention this before, but whenever you do your distribution, once you do that distribution, it's no longer necessary to hold on to the parentheses. So notice after we distributed the 3, then we can drop the parentheses because there's no need for holding on to them. So that's what we did here. That's why we have -3x minus 21. Inside of the brackets, though, we still can simplify. We have 2x minus 3x, and that'll give us -1x, which is right here. So notice there's no 1 there, though. So whether it be in WebAssign or in your book, you'll never see 1x or -1x. It will assume that if you see a variable, that there is a 1 in front of it. So if you saw a, they assume that that's 1a. So that's always going to be the case. Now, if you want to use one in your notes to help you keep, organized or whatever, you feel free, but you'll never see that in the book or in WebAssign. So that -x represents -1x. And that's what happened here. 2x minus 3x give you -1x. So now that we simplified as much as possible inside of the brackets, we can go ahead and distribute. Distribute into -3. That'll be a +3x plus 63. And then we can add our like terms, looking at 2x plus 3x, that'll be 5x plus 63. Good, good. All right, got one more. Just one with decimals. Did one with fractions earlier, so just decided to throw one in there with the decimal. So we have 0.05x plus 0.02 times the quantity of 4 minus x. So just like before, if something is right up against a parentheses or group of symbols, you go ahead and distribute that into the quantity. So that 0.02 times 4 is 0.08, and 0.02 times negative x, 0.02x. And then from there, combine your like terms, 0.05x, and that's minus 0.02x. And that'll be 0.03x plus 0.08. That's your final expression. All right. Questions on anything, anybody? Everybody good? Everybody in Zoom? Everybody all right? So, those are your first two sections. So once again, when you get into web assign, you should see homework assignments for those first two sections. Also, like I said before, our dean set up the shell, so I got to see how she went in and broke up the quizzes. But the quizzes will be based on, sections that she have, and it should all be laid out. But yeah, so just check it out. Now there is an assignment that's up there before B1, and it has like a whole bunch of stuff that deals with pre-knowledge that I talked about. So take a look at that, try it out. Of course, you want to do well on it. But if you have any questions on it, like I said, bring them to me so we can make sure that you're good moving forward. I know one person said how they had, some trouble with it, but it's stuff like fractions and sign numbers and stuff. So take a look at it. If you got any questions, y'all know how to find me. Other than that, you guys have a good one. Be safe, and I will see you. Now, is that a class or is that's a class question, just a personal question? Huh? Yeah, you can use a calculator. That's not a big deal. All right. So you guys have a great weekend. Let me cut off the recording real quick. Oh no, you're good. I'm just gonna cut off the recording.